Okay, I can dispose of this problem rather quickly. Because the key is you want to represent your information on a graph. So our information is f of -2 equals 2, and the 0.01 is on the graph. Now, what's f of -2 equal 2 mean? It means when x is -2, y equals f of x is 2. So let's just say, I like to use a dotted line. Y equals 2 here. I'll use this. This is your line x equals -2. Okay. So again, when x equals -2, this says that y is 2, which means this point is on the graph. So this is the point. -2, f of -2 equals -2. Then we have the 0.01. Well, right here is y equals 1. Y-axis is the line x equals 0. So we have this point. Now, what's the average rate of change of f of x with respect to x? I think I have the with respect to x in there. It's an important phrase. Open math tends to leave out. I kind of recommend leaving it in because there's something that comes up in calculus will make a lot more sense if you're used to leaving it in. Okay. So then what's the average rate of change here? Well, we've already seen in the earliest example, the video I did on the 101 function for version 4, the sample test. The rate can be identified with the slope between the 2 points. Slope between the 2 points is easy to get. And I'm not going to go into a full explanation. I'll say some words, but I'm not going to write it out. I'm just going to say the rise is 1 minus 2, which is -1. You subtract the y-coordinate of where you're going. Well, you subtract the y-coordinate of where you are from where you're going. So it's going to be where you end up minus where you start. That's your displacement. And that's going to be the rise. That's written kind of small and kind of poorly, but I think it'll show up on the video. Your run is going to be 0 minus 1, which is -1. And this is, the rise is your delta y, run is your delta x. Okay, so your average rate of change delta y over delta x. That's the definition for the average rate of change on an interval. And again, be real careless. I don't think I woke up that way this morning, but well, should be 0 minus -1 equals 1. So it's obvious that the run from here to here is 1. So -1 was going to make sense. When I started to write this out, I looked down here and said, wait a minute, that's not going to make sense. Fix it. I have to do too much of that. If you're a little more methodical in what you do, you probably won't have to fix as much stuff as I do. Of course, when you're first doing it, there's always fun stuff to fix. So I have no excuse to do. Okay, anyhow, delta y is -1, delta x is 1. So we get -1. That's the average slope. Okay, so we could even put a one here with a box around it. Go back to the very first video in this test prep series, and you'll see what all this means if you don't already know. Okay, so that one's pretty easy. There's another, they're all rate of change problems. And I think I'm going to, contrary to what I put on the website, I think I'm going to do 2 rate of change problems on the test. Now, let me just write down a few things for the other ones so you don't have to watch me assemble the information, but look at the next problem in version 4 and see what you would do. Okay, the information you're given is the graph of a piecewise linear function. I think I called it that. Well, I did say. Okay, the graph just contains 3 points. Okay. I think those are the points. So I took the liberty of sketching the graph, so I don't have to do that. Take up a bunch of your time. We have the point 1, 1. So we need the line x equals 1 and y equals 1, and at the intersection of those lines and y. 4, 5 means they need the point line for x equals 4 and the line for x equals y equals 5. I've already sketched. And then 8, 8. So we need a line for x equals 8 and y equals 8. And this is more or less the scale. Now we want the average rate of change on first interval and the average rate of change on the second interval. And then we want the average rate of change on the whole thing. So the rate of change on the interval 1, 4. Okay. Well, on the interval for x equals 1 to 4, we want the average rate of change. So we can find our delta y and our delta x easily from the fundamental triangle. You can do it from a formula if you want, but you learn much more if you understand both the formula and the picture. So the picture is we go from this point to this point. Here's our delta y equals out. Want to write it out? 4 minus 1 equals 3, and you count what? 5 minus 1. We're gone from y equals 1 to y equals 5. So we do 5 minus 1, and that's our delta y. And then we go from here to here, find our delta x. Delta x equals what? Well, x is going from 1 to 4. So that's 4 minus 1 equals 3. Well, then our slope, and I'm shortcutting this because we've already explained this previously. Whoops, I'll put it upside down. It's 4 over 3. Okay, so average rate of change, delta y over delta x equals 4 over 3, which corresponds slope between the 2 points. The average rate of change is not defined to be the slope, it's defined to be delta y over delta x. But you can see from this picture that is just slope. Okay. Now we do the slope from this point to this point. Okay. That gives this path. So delta y goes 5 to 8, it's 3. Smudge, still hard to read. Delta x equals 8 minus 4, which is 4. X equals 4 to x equals 8 divided by 4. So the slope is 4/5. Now I'm looking at what I'm going to do later. And my labeling is going to be in the way that it's, that represents 4 over 3. It's not slashes. And I can't read it at all now. So I'm going to integrate it and rewrite it. On a nice sharp corner of the chalk, that should do it. Now, also the average rate of change in the interval 1-8. Well, on the interval 1 to 8, I'm going to change the colors on you. Unfortunately, the slope line is going to go through my labeling here. So I'm going to draw it kind of lightly. So right there's a line, the x equals 1, the x equals 8. Right. Now I'm going to make it a little forward, except for I've gone through my points, so you can kind of still read the slopes, 4/3 and 3. Not 4, it's 4/3. Happy 4/3, 3/4, rise is 3, run is 4. Labeling, turn it around. And so if I can write this one through. And slope here is 3/4. Okay, again, the rise is 3, and the run is 4. It's obvious. It's obvious from the graph and the coordinates and everything, if we do even halfway accurately, that these two have different slopes. And this has the lesser slope, 3/4 is less than 4/3 and all that stuff. Okay, now for the slope between 1 and 8, the average rate of change between 1 and 8, I'm going to draw a triangle. Okay. And my arrows are going to go like this, left to right in every case, and then up or down, depending on whether this point is higher or lower than this point. Okay, so here my delta x . 8 minus 1, which is 7. And my delta y equals 8 minus 1, which is 7. So this interval average rate of change is 1. Now, this is on the interval from 1 to 4. And this is on the interval 4 to 8. And then I ask, is the average rate of change on the big interval equal to the average of the two average rates of change here? Okay. So the average first two rates of change is the average of four-thirds and three-fourths. And I'm sure that I'm on a range of the camera here. Most of what I just wrote, so let's look it over. Okay. What's the average? Four-thirds plus three-fourths divided by 2, because I average two numbers, you add them and divide by 2. Well, you do need diffractions, we emphasize that. 4/3 is going to be 16/12. and 3/4 is going to be 9/12. So that's 25/12 divided by 2, which equals 25/12 times 1/2, which is 25/24. It's not equal to the third average rate of change. Now that's a common phenomenon where it kind of makes sense that the rate of change from here to here ought to be the average of the rate of change from here to here and the average rate of change from here to here. It isn't so. And now maybe if these two intervals had equal length, because this interval has a length of 3 and this interval has a length of 4, between here and here's 3, between here and here's 4. Maybe if the two intervals have the same length, it would be, but something that we could test. But we're not going to go that far with it. We're just going to leave it at this and understand that the question asked for number 108 requires a little more construction and a little more calculation. But if you just keep your wits about you, it's not difficult. This problem requires that you be able to read the function notation and correspond that to a point on the graph. Those are the two things that I've chosen to test. Now you probably only get one of them on your test. It might be one or it might be the other. Okay. Now we have this stuff on rate of change applied. If I can find something more, I'll address that. Let's see that. Okay, so that's all I've got left to work on, but I think we can go ahead with this. Okay, once more. Rate of change application. So 109. This is rate of change applied, and it's pretty simple. The temperature equal 3, the temperature is 40 degrees. Equals 12, temperature is 100 degrees. Now, you can find the average rate of change easily. The average rate of change of temperature with respect to time is the change of temperature, which is 60 degrees, divided by the change of time, which is 9 minutes. So 60 degrees divided by 9 minutes. And you can work that out and you get it instantly. But the thing I want you to do here, and the thing I'm trying to condition you to do, is put the information on the graph. So I explicitly ask you to put the information on the graph. Okay. So we have a graph here. Now it's common to use capital and lowercase letters as different variables. So T itself is not your variable. Capital T is your temperature. Lowercase t is your time. And you want to label this time t in minutes, temperature t in degrees, not abbreviate degrees. So right here on the axis, we see all the information we need to tell us what this graph is representing. Now we have 2 points on the graph. T equals 3 and t equals 12. Well, okay, I'm going to do a vertical line here. T equals 12. Then I'm going to go halfway back to the origin, cut this to the middle in half. And of course, that's going to be t equals 6. Halfway between 0 and 6. And actually, t equals 0 here. And it conveniently, if I cut that in half, I get T equals 3. Now, the numbers I give you don't always work out that nicely with halfway and halfway, but you can still do a pretty good job of putting a scale on it by taking something around your biggest number and splitting things up. So you can do that any way you wish. Now, if T equals 12, the temperature is 100 degrees. If T equals 3, it's 40 degrees. Now, what I'm going to do is I'm going to put 80 degrees here. So T is in degrees, so T equals 80 means temperature is 80 degrees. So now I can get 40 degrees right here, right? And then I can reason out, well, that's an interval of 40 degrees. Half of that would be an interval of 20 degrees. And the 20 degrees plus the 80 degrees would put me about here. So here T equals 100. So now I've got a scale that more or less makes sense. You can do it any way you want, but I like the whole idea of cutting things in half anytime you can. Okay, so what is our information? What points do we put on the graph, in other words? Well, at T equals 3, which is on this line, temperature is 40 degrees, and that's on this line. So when this line meets this line, we have this point. That's the point. Sorry. I think before I write it down, I'll just write down the last number I looked at. T equals 3. Big T, little t is 3, big T is 40. And similarly, when T equals 12, the temperature is 100 degrees, so we have like 12, 100. And then I say, what is the average rate of change in temperature? Expected time of the corresponding interval, include your units. And at this point, you don't have to draw the triangle and you don't have to label the graph. Somehow you're going to have to convince it, right? And I really recommend that you use a graph whenever you can. So I'm going to draw my fundamental triangle up here. It's kind of hard to label. There's the space I've given myself. Okay. Delta Y for delta T. Okay, the average rate of the temperature of expected time is change in big T over change in little t, change in temperature divided by the change in time. Obviously, if you look at the graph, your delta T is from 40 to 100. So that would be 100 minus 40 equals 60. And that your change in little t is 12 minus 9. I'm sorry, 12 minus 3, which is 9. Now that's on the graph, where the graph tells you that big T is in degrees and little t is in minutes. If I take this information from the graph, get big T with delta big T equals 60, that means delta T big T is 60 degrees and delta little t is 9 minutes. And well, 9 goes in 60. 6 4/9, okay, which is 6.44, and it's degrees over minutes. I prompt you on this thing to include the units of the average rate of change. Now that's automatic. You should always do it whether you're prompted or not. In this case, though, I prompted you to remind you that I want to see the degrees over the minutes, and I want to see the degrees over the minutes in this calculation. And I want to see degrees labeled on the graph, and I want to see minutes labeled with T on this graph, time T in minutes, temperature of 18 degrees. Okay. Now, if you leave some of that off, I am going to penalize it, but maybe not harshly. If you get down to this and tell me it's 6.44 degrees per minute, you're probably going to get at least 7 points out of 10, but I'm going to want to see documentation. Okay. I know if you got the right answer, you knew how to do it, but I want to see how it's done because I want you to develop the skills that are going to help you build into the rest of the course. And one of the skills is just this. Okay. Now on the number 110, which is also rate of change applied. I'm just going to draw a picture. So in case of the picture is weight, capital W in pounds. Now use the LB. That's your vertical axis. Your horizontal axis is time. T in months. Okay, kind of small. Maybe I'll zoom the camera in on it a little bit in case you can't read it all. It's not written very well, but it's later. And what you have is 26 pounds at a certain time and 56 pounds 8 months later. So I'm going to say it's 26 pounds here. And I'm going to assign that time 0. I don't say what the time is here. All I'm saying is that the next time is 8 months later. Okay, so I'm just going to arbitrarily call the time here 0. And the weight 26, meaning our initial time 26 pounds. Okay, and 8 months later, well, you're going to have T equals 8 here. Say T equals 0 here. T equals 8 here. And we're up to 56 pounds. So here's the point. 8, 56. Here's our final. I'm not going to write out all the details, but you want to write them out like I have. You should have rise equals 56 minus 26 equals 30. Well, actually, I can write that 56 minus 26 equals 30. The run equals 8 minus 0 equals 8. So that, and this of course is delta little t, and this is, I'll say delta W. If you want to call this weight Y, that's okay. But I'll use W just to do this. So average rate of change equals delta W with the delta T. Now we put the units in. It's 30, but on the W axis, the axis corresponds to the rise, it's 30 pounds over 8 months, which equals 3.75 pounds per month. And the instructions in this are the same as the instructions in this one. So we do want to see the construction and the details of the reasoning. Okay, so that leaves 2 problems on composite functions. I don't know if I have any more clean board to work on, but if I don't, then I think I maybe don't. I'm sure they wrote in back to them. I think we did. Yeah, all over the. Okay, I'm going to pause the video, clean a board, and then we'll wrap this up rather quickly. Okay, turns out I'm probably not going to have to clean a board. I don't think I need much room for this. Let's see. So this 111, 112, composite functions. Okay. Now 111 has h of x equals -5 for the quantity -5x plus 5 squared. This equals f of g of x or f of x and g of x. So what two functions would you combine as composites? Well, the first thing that happens to x is g of x. The first thing that happens to x here is you do -5x plus 5, right? So we could immediately let g of x equal -5x plus 5. And then what does f of x do to g of x? Well, the -5x plus 5 is put under -5 and square. So we can say f of x equals -5 over x squared. Thus, f of g of x is -5 over g of x, because again, if f of x is -5 over x squared, which would be g of x squared. Okay, if f of x is -5 over x squared, then f of g of x is -5 over g of x squared as and that's -5 over the quantity -5x plus 5 squared. Okay. Now you could also say I'm going to write this about comment because it should be pretty obvious. Use g of x equals -5x plus 5 squared. And f of x equals -5 over x. Then again, f of g of x equals -5 over g of x, not 5 over g of x squared. And g of x already has the square, so it's -5 over -5x plus 5 quantity squared. Now that's kind of spread out all over the place. This is written pretty clearly. Take a good look at this, you see what I did there. And then for number 112, well, I don't have much room there, do I? I've got the room on these others. I've got to pause for a second. Okay, I'm going to have to do this here. I'll leave this. But we have this h of x, and we want to do the same thing. Want this to be f of g of x. Okay. Well, you see, yeah, that's right. I had a plus here. Until I just erased it as you saw. If this was 2x plus 5, there's not much we could do. But we got a 2x minus 5 here and a 2x minus 5 here. This tells us we could let x equals 2x minus 5. And now f of x be what? Well, here's 2x minus 5 squared, so that would be like x squared. And here's 1 over 2x minus 5, so that'd be like 1 over x. So then, f of g of x equals what? Well, f of x is x squared plus 1 over x. If you replace x with g of x, which we've done here, then you got to replace both of these x's with g of x. So that would equal g of x squared plus 1 over g of x. And of course, since g of x is 2x minus 5, g of x squared is 2x minus 5 upon x squared. G of x is 2x minus 5. So g of x squared is 2x minus 5 plus 1 over g of x. Well, that's just 1 over 2x minus 5. So both of these require that you be able to figure out what functions you have the composite. So make sure you pay close attention to that and understand these examples as best you can. Might be a little challenging, but you've had problems of that nature in your homework, and if you've done your homework as carefully as I hope you have, and I know most people probably haven't, because it's a habit you got to get into. The habit you probably didn't need in high school. Habit you're going to need here. So get into the habit. Now, just to see these things a little more clearly, I'm going to zoom the camera in a little bit. So if you are having any trouble seeing it, hopefully you'll be able to see it now. Let's just, oh, that was the wrong way. Okay, so let's see now. We're going to zoom in. Let's go up just a little bit. Come on, well, that's too much. We'll try it. Okay, zoom, come on, zoom. Okay, I'm going to zoom in quite a bit. Then I'll go up. This thing doesn't work very well. Camera's very quality, remote. It's kind of bad that the remote is the only way to zoom the camera. Okay, and it's got to be aimed just right. Okay, so right there is the 110 problem, in case you were able to read everything. Okay, and we're going to move down. And I think we can see the whole 112 problem we just did, right there, all the details. And then let's see what we can do with the 111 problem, which is this one. Now you can probably see the alternative, but let me show you the, well, I hit the right button. That was my fault. That wasn't the remote. Okay. So here's 111, which again, -5 with 5x plus 5. You're taking the -5x plus 5, you're putting it in the denominator and squaring it. You can do all that by just letting g of x equal -5x plus 5 and see what f of x has to be. Okay? Well, it's going to have to equal -5 over x squared in order that the composite equal this. So you want to write out all these steps. Then you want to look at various questions. You have 4 samples. Probably want to look at this in all 4 samples to see what the variety of the questions might be. An alternative was to use g of x equal -5x plus 5 squared, where we just use f of x equals -5 over x, so that -5 over g of x is started. Okay. Okay, so there we have it. Yeah, that's probably 2.5, 3 hours of video. I haven't looked, but tells you pretty much everything you need to know in order to do well in this quiz. zoomed in so far, I kind of look monstrous there. I do anyway, but so I'll get out of the camera, but there it is. Okay. Good luck in the test. Let me know if you have questions, want to write stuff out and upload it or email it with questions. I'll be glad to look at your work and give you as much feedback as I can. And also, I'll probably put this in writing, but the test will still be next week. I'll be able to get that in the testing center not later than Monday afternoon. If anybody wants to take the test Monday morning, matter of fact, I might even be able to get it in Saturday because I think the library and stuff will be open on Saturday. Not sure how early I can get it in there on Saturday, but at least then it would be available early Sunday, or early Monday. So again, good luck. We will answer questions. This test is reasonably accessible. You know exactly what you need to be able to do. It's pretty easy to predict what you're going to have. If you look at different versions of the test, you'll see a lot of similarities. Now, to be clear, there'll be two problems, 101 through 103. There are three problems there. I'm going to ask you to do all the stuff I did in that one first video. Okay. Then you'll have a problem on inverse functions. It'll be like based on one of the two problems that you see on inverse functions. Then you're going to have rates of change, and there'll be two problems, as I mentioned. Two problems where you just have information on points, not applied rates of change. But there'll be one problem on just plain old rates of change, and a second problem, one problem, but on the applied rates of change, where you got to put the stuff on the graph, as you saw recently. And then the composites, and if I left something out, I don't think I have, that'll be it. I think that'll be 6 problems. The grading will be such that the two problems you have, we've got to answer all the questions and build that graph and everything. In other words, the problem and solution is going to look like this. And that's not all of it. Remember what I did. That's going to count more than the other problems, so that those two problems will be half your grade. Those two problems will at least be worth like 25 points. And then there are 4 more problems that'll be worth almost 50 points, something like that. I'll put that in writing to be sure you understand that. Okay. In other words, you just about pass the test if you do this, do it right. And then you build on that. Now, I really want to see people master this to the greatest possible extent. It'll build your confidence if you can do that. Everything you do well is going to build your confidence, and it's going to give you a basis for everything that well, I can't say everything, but for much of what we do for the rest of this term, as well as future courses. So spend some time, do a lot of review practice, work these sample tests. If you want more sample tests, I'd send you 1,000 of them if you want. Well, probably not going to, because nobody's going to use them. If you want even 10 more, just ask, I can just press the button. Okay. And there wouldn't be sample tests, it'd be sample problem banks and problems in the problem bank, and they're pretty predictable. Okay, I don't mind giving you a pretty predictable test here at the beginning, because these are the skills you need to master. And if you can even master them well enough to remember them long enough to imitate them on a test, since we're going to be using them again and again, you'll have to see it will grow into a lot of knowledge for you. Okay, so good luck. Sorry we didn't have class today. A couple of these videos will be worth more than the class would have.